Sofia Jimenez, the effect of language ability on speaker identification.
Hello, everyone. So I just wanted to give a little bit of background to my honors thesis presentation. I've been working with Dr. Sarah Creel in her language development lab for around 2 years now, and I've been really interested in researching speaker identification and how people are able to identify different speakers by their voices. And also lately I've been really interested in the varying language abilities among individuals and how does language ability correlate to speaker identification. So there's a lot of information that we can pick up from a specific voice signal. So when we hear a speech sample like this,
Please call Stella. Ask her to bring these things with her from the store. 6 spoons of fresh snow peas, 5 thick slabs of blue cheese, and maybe a snack for her brother Bob.
there's a lot of things that we're processing. Probably most obvious, we're understanding the words, we're understanding the grammar and the meaning of what is said. And this has been the focus of most language research so far. But we're also not only are we understanding what is being said, but we're also understanding information about who is saying it. So we can pick up that this is a female speaker. We can, if we have information about, if we have prior information about the language background, we can tell that she's from the Midwest. And if you already knew the speaker prior to hearing this, you would be able to identify the individual. So all of this involves voice recognition. So voice recognition is a complex ability. You can probably pick up on this from like smartphone usages and how hard it is to get a phone to understand what you're saying. But humans also have a hard time. Not only, well, they learn to understand what you're saying, but also who it is that's saying it. And there's a developmental increase in learning this. So my previous research showed that preschool children could not identify voices as accurately as adults could. And so this shows a developmental effect. You get better at identifying voices as you grow older, and we want to know why this is. If this developmental effect is because adults are just smarter, or they're better at learning things, they have a better memory, or is it because they have more exposure to language, and that's why they're better at identifying voices because of their increased language knowledge. So there's been a lot of previous research done on the correlation or the relationship between language knowledge and voice recognition. First of which is research done on language, native language effects. So this means that you're able to identify speakers better in your own language. So if you know a language, you'll be able to identify the speakers in that language. And so an example, if you speak Spanish, you'll be better able to identify someone else who's speaking Spanish than someone who's speaking German, for example. So not only are people able to identify speakers of their own language, but also of their own dialect. So research was done by Perchone on African American vernacular English and mainstream U.S. English, and they found that speakers in a certain dialect were able to identify individuals in that dialect better than outside of that dialect. So that's another piece of evidence that leads us to see this relationship. Age of acquisition is also a thing that was very recently found in our lab that's been found to affect voice recognition. So the age that someone acquires a language influences how well they're able to identify voices. So if you learn English later on in life, you might not be able to identify speakers as well as a native language learner of English. And then our last piece of background information that we got was that dyslexic adults are worse, show poor performance on a voice identification task. So this is very interesting because dyslexia is a reading disorder that is thought to be related to impaired phoneme processing. And this phoneme processing means how well you're able to process sound knowledge. So they tested, Perchon et al. Did this recent study where they tested dyslexic people and found that they were worse on average than normal reading ability at identifying voices, and that might be linked to their language knowledge. We want to see how pervasive this relationship between language and voice is. So will we not only see a distinction between normal and dyslexic, but will we see a correlation among the typical population? So we want to test native English speakers and see if adults can, with their continuum of abilities, if we can see a difference between those who have worse language abilities, will they have worse voice identification abilities as well. So we're going to be doing this instead of doing this with children and adults, we're going to do it within adults and see if this relationship is there. So a couple things we know about voice identification and language knowledge is that voice identification is thought to be in the right hemisphere of the brain, and language knowledge is thought to be in the left hemisphere. And language knowledge is actually a very broad spectrum. It encompasses a lot of different components. Two of the components that we'll be focusing on are word knowledge and sound knowledge. And we want to see how these correlate to voice identification. We picked these two because we thought that they would be two that would make the most sense. Learning voices might be like learning words. Like the better you are at learning different, picking up new vocabulary, you might also be better at picking up different speakers. And the sound knowledge is also really important because every language has a different sound set, and so once you pick up this sound set and once you're able to work with this, that knowledge might relate with voice identification knowledge. Okay, so how we tested this was we used 30 UCSD undergraduate students, and they all underwent a voice learning task. So this was a task that was on the computer, and I'll be showing how it went later. And they also underwent 2 language measure tests. So I tested each participant's vocabulary size using the Peabody Picture vocabulary test, and their phonological processing using the comprehensive test of phonological processing. So we want to see if there's a relationship between these language measures and voice learning task. So the first one I'll explain is the voice learning task. So the participants would be in front of a computer. They'd see these 2 faces, and they would hear a voice.
Did you fall asleep?
And they would pick if it was the right or left face that they thought that the voice correlated to. So they would make their response, and then the correct answer would stay on the screen, and then they would go on to a next training trial. So they'd see the 2 voices. Again, they would hear a voice.
Fog feels cool.
And the correct answer would stay on the screen. once they picked their once they reached a criterion, so once they moved on, they could go to testing, and the testing would be very similar.
Who's he spot?
And but in the testing there was no feedback, so they just stayed on. So this voice learning task it involves learning 8 female voices. You heard 2 examples right here, and they were all they all had the same accent, around the same age, and so that was important because we really wanted to see if people could pick up on individual differences that weren't, I guess, like so obvious. So these female voices had each were saying 3 phrases, and these phrases each had 3 vowels. So they had e, ah, and oo. So who, sees, ought. You could hear those 3 vowels are in there. And this is important because it gives the listener a good idea of the speaker's vowel space. So then they got feedback, and so they would start off by guessing, and then slowly they would learn which voice went with which face. Each trial was 56, each block was 56 trials long, and within each block, we would test until they got to 85% accuracy. So each participant varied in how long it took them to reach this criterion. So one of the language measures I talked about was vocabulary. So this is a Peabody picture vocabulary test. Participants were asked to point to the picture that best represented the word that they were given. So for an example, I could ask you to point to salute, and you'd point to the picture that best represented that word. The comprehensive test of phonological processing had different parts, and it had a few different tests for each category. So we tested phonological awareness, and so this is the knowledge of how the sounds of the language go together. So an example task would be say winter without saying t for phonological awareness. And for phonological memory, we had tasks that involved remembering, using working memory to keep sounds in words and then say them back. So for the phonological memory, one of the examples was memory for digits task, where the participant would repeat a sequence of numbers back in the same order that they heard them. So just to go through like the results that we got. So the time that it took people to learn voices actually varied a lot between participants. So some people, you can see that this is the individual number of participants against the blocks to learn, to reach criterion. So some people took 1 or 2 blocks to reach 85% accuracy, and some people, it took them longer, so they had to repeat more trials till they got like to 6 or 7. There's also a wide range of scores on the PBBT, the vocabulary and the phonology tasks. So each point here represents an individual participant's percentile on the test. So someone here, for example, would score in the 20th percentile for vocabulary, and you can see that there is a large range of scores for both measures. One thing that I wanted to note was for the phonology. This is a task that is given to dyslexic people. None of our participants actually scored for dyslexia, so that just confirms that we're doing this among a typical variation of language abilities. These are all UCSD students, and there's people who scored above average, average, and below average test scores. Okay, so some possible outcomes that we could have. There could be no correlation between voice identification and language and a specific language measure. So this would be the percentile of the language measure against the training blocks would have no correlation. And then there could be a strong correlation. So I just wanted to point out that it would be actually a negative correlation. So we would expect someone who scored a higher percentile, like 90 percentile, in a specific language measure to use less training blocks to reach criterion. So possible outcomes is we tested 2 language measures, as you remember, vocabulary and phonological processing. So either there could be no correlation between any of these. There could be one of them could show a correlation, one of them couldn't, or both could. So the first one that we want to look at is word knowledge. So this is the vocabulary and how that correlated with voice identification. What we found was that there wasn't very much of a correlation. So having a larger vocabulary did not give you an advantage on learning the voices faster. So even people with comparatively good vocabularies could take a long time to learn the voices. So next we wanted to look at sound knowledge and see if there was a correlation there. And what we found was there's a much stronger correlation. So the better you were at processing sounds in a language, the faster you were at picking up voice and learning voices in my language test. So we did a linear regression on this data, and we found that the correlation was significant with a p-value of 0.0005. And there's also these 4 people that scored on the lower range for phonological processing. You might think, well, maybe they're driving a correlation, but when we took them out, there was still a significant correlation between phonological processing and time it took to identify voices. So just to summarize the results, phonological knowledge did end up predicting voice learning and vocabulary did not. And this was the result even though the PPVT, the vocabulary, and the phonological processing tests were correlated with each other. So in conclusion, phonological knowledge and voice identification learning are tightly linked, and so this shows that all language ability is not tightly correlated with voice identification. It's specifically phonological knowledge. And typical adults, and not just dyslexics, vary in their ability to learn voices. So if you think back to the Periccioni article, the relationship between phonological knowledge and voice identification still stands when you test the typical adult variation. So when we tested sound knowledge, that ended up being a strong correlation. So now there's a future direction where we could go is testing all these other parts of languages and see what else correlates with voice identification ability. Thank you. Anyone have any questions? Yeah.
Did you look at gender differences at all in your sample?
Yeah, that's a good question. There were actually a lot more women than men. We only got 6 out of 30 of them were male. So that might be because there are more women in psychology, or I don't know. But with that data, I didn't find any differences. But it would be interesting to try to like run more male participants.